The Constraint Manager is the biggest thing that I use to evaluate a PCB design software. A PCB design ECAD software is only as good as its Constraint Manager, in my opinion, because the Constraint Manager enforces the rules and requirements, well, the rules we need to meet our requirements. And if we don't meet our requirements for the product, we have to redo the board anyway. So the Constraint Manager is the most important thing. It's like the referee for the game, or the rules of the game, right? If you don't play by the rules, you're not gonna win the game. All right. This is the first PCB design software that I see that has the images that pop up. Welcome, this is Tech Ed Kirsch. In this video, I'm going to be reviewing the Xpedition Standard software from Siemens, or for those of you who are OGs and coming from Pads Pro, whatever, the Mentor Graphics, formerly Mentor Graphics, now Siemens Xpedition Standard Suite. If you're looking at the different ECAD software, trying to figure out what is going to be a good solution for me as a hardware design engineer, a professional hardware design engineer, not hobbyist, okay? You're doing professional designs, but you don't know which ECAD software to choose or which one is going to have the features. Don't worry, I've done the work for you. In this video, I'm going to be answering your questions surrounding schematic design. Am I going to like the schematic design experience? Does it have the features I need? What about the core design capabilities of the software? What all can it do, really? Are critical features missing in the standard license that I need to get an upgrade for? What about PCB layout? Is it easy? Is it intuitive? Is it really worth doing or using this tool, learning it? How much high speed can I do? Can I do all high speed? Are there limits? What about signal integrity? And so many more things, okay? So this is a review video. If you don't know me, I am an electrical and electronics design engineer. I've done everything from power systems in industry to electrical hardware design systems. I've worked as an electrical systems engineer and a hardware PCB designer, even at Intel headquarters in Silicon Valley. And I've worked as a senior electrical engineer and senior field application engineer in multiple ECAD software and hardware design, electrical systems like MATLAB Simulink, Cadence Allegro, Altium Designer, KeyCAD, you name it. Okay, so if anybody knows what they're talking about when it comes to enterprise level software and being competent in the industry at designing boards for corporations and for big volume, it's me. So you're going to want to watch the rest of this video or listen to it like a podcast or whatever, and I'll give you the tea on everything you need to know about this software. Oh, and also pricing, whether it's worth it or not to buy, or is it too early, whatever. Let's dive in. So the first thing we're looking at is installation. I tend to judge software based on how easy or difficult it is to install. I know, sounds kind of weird, but that's what I do. So to the point, this software is very easy to install. I just needed to get the download files and double click on them and install them. Now I got two different download file packages, one for the main Xpedition Standard tool and also one for the extensions that includes HyperLynx and some other things. Important note, HyperLynx is not installed in the default package of the software. You get that as an add-on. Very easy. I love the cloud installation process. Much easier than the dongle process. So installation, that's an A+ for me. Now the first thing is schematic capture. Can we do hierarchical designs, component library management, design rule checking? How does this work? For the schematic capture, yes, we can do hierarchical designs. In my opinion, it works. It's a little weird though. So let me show you what I'm talking about. If I were to open a design and open this flex wearable design, it's easy to do that, so that's great. Your schematic opens up. A lot of these panels on the bottom are taking up a lot of space, so you can remove those. It looks clean. I like the clean look of the software and the environment. On the left, you can navigate the hierarchy. This is your main folder or project. Then you have your boards. They have multiple boards you could put in here. Then the folder for your flexible board. Then your schematic. Your schematic will have sheets in them. And here, this is by nature hierarchical. You have one sheet, and then you can double click and open another sheet. It also has a list of all your components right in the sheet hierarchy. So you can click on any component within the list without having to find it on the schematic. I really like that. The next thing is how easy is it to place components. To place components, you would place parts like you have your Project Explorer You can do manual part replace, but let's go place parts, right? How easy is it? You pull up your Project Explorer. This would have your library of parts available. Then you just click on the part and you can choose to place or do replacement of parts. Very modular, very professional. And then it has these different slots, fixed cells. You can add nets to this thing and labels. I mean, that's pretty crazy. And then you click on the down arrow and you can see the preview of the part along with its schematic symbol and the PCB footprint. The view is a little primitive, but that's okay. At least we could see the part, and this may pull from some database or whatever, and you click and place it. So I like that. I also like that the part stays attached to your cursor and it has alignment, okay? Alignment options, so you could line these up. Very cool. So if I click on here, I double click, no problem. Let's see if I can drag it onto the, see, I can't drag it on the schematic. That's okay. I do like being able to double click on things and then click and place them. So that's pretty good. You can also do Control Z, your standard Control Z to undo things. Click on a component and delete that. You can do a Control Alt to select all components and they get pulled up in the design. So I like that as well. Navigation, you could scroll in and out to zoom. Well, scroll up and down to zoom in and out, pretty standard, and I like that as well. There's so much more we could talk about with schematic. Like, well, actually this key thing, the constraint manager being inside the schematic. I can access the constraint manager here. So go to integration and then choose constraint manager. This is something you're going to need, okay? If you're a electrical design engineer who's designing printed circuit boards and hardware, you're going to want software that has the constraints driven design approach, okay? Or design right by construction is what Siemens calls it, I believe. You want to have your constraint manager available from the beginning of the schematic, defining your net classes at the schematic level, your clearances, okay? Your electrical clearances and whatnot. You may not know what those are immediately, but usually you should be able to, like a minimum of at least 5/1000ths of an inch, okay? For 500 voltage withstanding, okay? And then you're going to put as many constraints in here as possible, including for your parts. Depending on your design requirements, you're going to immediately know. You're going to know what parts need to be far away from, what parts need to be on the edge of the PCB, and how far and how close to the edge of the PCB they can be. So I like that the constraint manager is in here. This should be standard for all professional ECAD software tools and software tools in general. Why? Because all of PCB design and schematic capture stems from the requirements, okay? And the constraint manager is what enforces those requirements for your project. All right. So I just wanted to show that and how cool that is. You can assign net classes to nets. You can set your 3D clearances. I was going to say DDR, and your electrical rules and analysis and reports. So that's just a quick introduction to the schematic side constraint manager. It's the same constraint manager. Very cool. The next thing is DRC verification. You can do a quick verification on component menu and take a look at that. Text alignment, your different interconnectivities. It'll let you know what warnings or errors you have. And you can do a drop down and then you can click on each of these to find out what component or net, whatever object is causing that warning. You also have pin type verification. So it pulls up the properties for any of the pins you select or whatever the case is. And then you can verify that it's the correct type. In fact, somebody commented on one of my videos to find out how important is the pin type to specify or verify. It's very important, especially for debug issues. You don't want to have an output pin connected to another output pin by mistake just because you set it to unspecify and forgot to check something in the datasheet. You don't want that. With the right pins, it does inherent debugging for you, makes your life easier. Something important, if you're looking for simulation in Xpedition Standard, it's not there. It's in the enterprise solution for the software, but you can export items from PartsQuest into Xpedition Standard. Next, let's move on to component library management. The library manager is its own thing, so you need to go to your application launcher, then choose library manager. So I like that you don't have to close the application or open a different application from the start menu in order to launch your separate application. So here we go to an existing library. You can import symbols to your component library. So you can go to File, Import Symbols, and you can start importing your symbols from different places. Next is the part editor, where you can edit your parts And then here we have the symbol editor. The symbol editor loads the library in a different window. So then you can go to File, New, and create, say, pins. So let me show you. Place a pin. Then you can start placing pins onto your canvas. Just like most ECAD software tools, set your properties, also the pin types. What I really like is how many pin types there are, especially with that tri-state pin, OCL, OEM out, ground, and whatnot. Not just your standard ones that will force you to have to make an unspecified pin type. Then you can go to wiring and drawing, draw boxes, draw lines, draw arcs. So let me show you how to draw a box here. You can also edit the text, just like pretty much your standard flow. Let's go ahead and close this. And that's it for the schematic symbol editor. Next, we're going to go into PCB Layout. In this PCB Layout section, we're going to be covering things like layer stack management, component placement, how does it deal with things, and design rule management. High-speed design and signal integrity, those will be addressed in the next section. All right, so here we have the menu. Once you open your software like Layout, you have your designs that are available. You click on any of the designs, and then you're able to open it. I also like that there are videos here that explain how to navigate this layout tool,
common design,
along with comments and everything. They talk about predictive commands, searching to find commands. That's pretty cool. So if you don't know something and don't know where to find a command or whatnot, you can actually search for it. Okay, let's get back to our flexible wearable design. We have a menu on the side here. I like that the menu is all on the left and you have your drawing options on the right. I hardly ever use this, honestly. And then you have your display control, which is fine. I don't like the pan, like the way it pans. And I also want to see my 3D feature option immediately available. You have to do like another thing to make 3D available. I don't like that. I want one button that shows it immediately. Anyway, let's go to the menu. Here we have things like being able to open our files, of course, importing drills. You can import DXF and Gerbers. That's a big thing. To view your Gerbers, I don't want to use a different software. I just want to be able to import Gerbers if I want to, right? And then make routes and decisions based on those Gerbers. Especially if you're trying to do some reverse engineering or figure out what nets are connected, then that's what you use, okay? Then we have measure minimum, measure distance. So it has these measurement properties that are pretty cool, pretty standard. And then the selection list. With the selection list, this is kind of like a filter is what I'm thinking. So a very modular spreadsheet approach to being able to do your selections. The most important thing I look at is the constraint manager, but we'll get into that a bit. And a quick detour, if you want the layer stack manager, you can go to your constraint manager. So you want to go to constraint editor, and in here in the constraint manager, they have the layer stack up. I can see why they would do this. So you have your signal and plane layers, and then you can set your rules for these different stack ups. Okay. And then adding any trace via properties, nets, parts. Okay. Well, we're going to go into the constraint manager. The constraint manager is the biggest thing that I use to evaluate a PCB design software. A PCB design ECAD software is only as good as its constraint manager, in my opinion, because the constraint manager enforces the rules and requirements, well, the rules we need to meet our requirements. And if we don't meet our requirements for the product, we have to redo the board anyway. So the constraint manager is the most important thing. It's like the referee for the game, or the rules of the game, right? If you don't play by the rules, you're not gonna win the game. All right. So now in the constraint manager, you do have things like your standard clearances and constraints. I also like how the constraint manager is laid out, being able to create net classes, expand everything as well, and clearances, your standard clearances. There is enough granularity here where you can set constraints and clearances for most any design, especially including high-speed design boards. What I also like is the icons and the pop-up notes that let you know what each of these things are, including images. Very important. This is the first PCB design software that I see that has the images that pop up. Actually, not the first, but done in this way. This is what should be standard with every PCB design software. I want to see in context right there, what are you saying this constraint is supposed to be managing? Okay, right there. I don't want to look it up, interpret things and all that stuff. I want to see it right there. Okay, so they did that. I like that. And I think yeah, anyway, next we have topologies. You can organize your constraints or your constraint classes and set the topology for that. They have the MST, they have chain custom topologies. Very important if you're doing like DDR3 still or DDR4, whatever the case is, or any kind of topology. Then you have your parts, your different parts list. They have constraints for these, including, very important, the IBIS model, your IBIS component name for that part. Okay, this is a whole other ecosystem. You can do IBIS models embedded inside the library of parts or your constraint management right here. You don't need to do a separate setup and all that stuff. You can do that. You get the point, right? You get the point. And then you have your type IO and everything, and you can look at your IBIS models. Very cool. We'll get into that when we get into signal integrity and HyperLynx in the add-ons. But this is just what's local in the software. So now with your IBIS models available, with your clearances available, with your traces and VIA properties and everything, you can set your VIAs. There's so much to go in here. But anyway, the basic idea is that you can route high-speed boards with this thing out of the gate. That's the key thing. So if your trace properties, this is your differential impedance, it will automatically calculate your trace widths and whatnot depending on your impedance. So if I were to say, you know, my default traces, I could go on here. This is your typical impedance, and you could set that, and you can modify it. I can't right now, but you can modify it and it will update and calculate automatically. So it has this field solver doing its thing. For physical rules, you have 3D DRC clearances. Very important for any PCB designer who is doing any kind of board. You need to be able to verify 3D, okay? Whether it's board edge, component, mechanical, PCB assembly, it has that, okay? You can create new clearance rules, class to class clearances, very important for differential pairs that need to be away from other differential pairs, like a USB for EMI purposes and whatnot, a USB super speed especially. You want them far enough away from other traces of the same group or class, and then have those classes and nets far enough away from other nets in general that are not part of the same class or group. Then you have general clearances, cavity inside edge to parts, pad to resistor, and so on and so forth. I wish there was a DFM specific category or area. I don't know if they'll add that, but I was expecting something like a DFM, DFX kind of box here, right? Because I'm not seeing them specifically. You can embed those kinds of rules and constraints in here in the main thing, but I like the category separate in and of itself. Just like how they had the physical rules, 3D DRC clearances. Where are my physical rules designed for fabrication, designed for assembly, designed for test? I think that's important. But that doesn't mean you can't check for manufacturing rules. So you go to Analysis and Reports and Hazard Explorer, then you can check for your DFM rules. For a more integrated DFM solution, that is in the Enterprise edition of the software. It is not in Standard yet. I also like that you can right-click, mark as, copy, cross-probe your different constraints, and that's the Constraint Manager. The Constraint Manager also automatically does calculations on not just impedance control, but timing for your different nets, and for signal integrity, EMI, and high-speed digital design. Here I can go to the constraint editor. This is new. So if you want to select certain traces, modify them, set electrical nets and everything, you can use the constraint editor to make very fine-tuned granular changes to constraints. So the constraint manager is your high-level overview, your overall constraints. Your editor edits specific constraints for specific components, nets, specific net groups, and so much granularity. This is the first time I've seen a constraint editor and a constraint manager separate. And at first I was confused, but it does make sense. And you can go back up to the constraint manager to manage all of your general overall constraints. Okay, so now that we're talking about constraints, let's jump into high-speed digital design and constraint. But what if I want to right-click and see, right-click group? Maybe I want to group based on all columns. How about that? There we go. Once you set it to all columns, then we can look at all of the constraints. Display pattern, stub length, number of allowed vias. Check this out. Defines a maximum number of vias. You want to do this like when you want to limit yourself to 2 vias for super speed receive or transmit differential pair line, differential pair, and you can only set it to 2 or 4 vias max or something like that. And the actual number of vias, the test points, Restricted layer length, very nice. This is to reduce any issues that might occur with the signal layer length for potential reflections depending on the rise time of your traces, and also maybe EMI or something like that. So from to constraint, layer trace width, nice. You could set your layer, also the Manhattan length and length in general. The formulas, check this out. Defines a formula used to create length or delay relationships. That is fantastic. And then you have the static overshoot, static low overshoot, ring back margin, single-ended characteristic impedance differential. These are all the constraints we effectively are going to need for any high-speed PCB. So I love that it has the constraints for your high-speed signals. There's also length matching you can do, right? So if I go into my match, it explains here, defines a match character or string you can use to group nets for similar length routing. You can define this value for individual nets, pin pairs, and differential pairs. Fantastic. So it has length matching in full. Also impedance control, which I showed in the basic signal integrity, basic impedance control constraint, and then there may be timing constraints for setup and hold times. Not sure if it does have timing. I'm pretty sure it would though, because you even have IBIS models in here. So I'm pretty sure maybe that's a property that's in the pins. I didn't dig deep enough into this for a first impression video, but I'm sure I'll find it if I build a board. Then we have signal integrity analysis. Once I handle signal integrity analysis, we'll get a bit into routing. So for signal integrity, what you can do is select any of your nets, right click on any of them, and then open up the display net and HyperLynx line sim feature. This is only applicable or possible with the add-on. You just install the add-on tools. So HyperLynx gets popped up. This is HyperLynx Signal Integrity Power Integrity tool. And look at that. We have our signals doing their thing. You can right click on these transmitters and receivers and assign specific models, manage model selectors, buffer directions, the stimuli. So you can right click on there, and we are in the world of signal integrity. This is on the signal integrity side, right? It has these features like the IBIS signal, the IBIS pin model. You double click on here and then choose the signals you want to work with. This is a whole suite going on here. It's literally HyperLynx. If you're not familiar with HyperLynx, it is a tool that lets you do in-depth signal integrity analysis. It has I don't know if it's 2.5D or 3D field solver, but it's very good and easy to use. Then it got integrated and wrapped up into the Xpedition software suite, so it's part of that. I don't think you can get it separately. IC buffers and MOSFETs, it has all these different kinds of resistors, passives that you can add on here right in the circuit. This acts as a signal integrity playground for you as a PCB designer. So you need to know a bit about signal integrity, or you could be a full-on signal integrity engineer. This would be where you'd be living, okay? Once you update your settings, do your simulations for eye diagrams and everything, then you can backpropagate your findings as constraints into your PCB environment. So great, very great that this is integrated in here. Again, this is an add-on, not part of the standard package by default. No, you have to purchase it. It's an extra money. And we'll get into pricing later. I think every PCB design software tool should have this as a default. Now, most EDA software tools have 2.5D field solvers if they're using field solvers, but Siemens has this fuller HyperLynx suite that has advanced solvers, including hybrid and full wave solvers. So you can download the brochure. They have design simulation, performance optimization. This is as a separate suite entirely. So the HyperLynx we were looking at within Xpedition is the add-on, whereas this is the fuller suite. Oh, and here's Dan Beaker. Okay, if you don't know Dan, he's a top guru in the signal integrity and PCB design space. Now let's talk about advanced design features. You can do rigid flex design in here. In fact, I have a rigid flex PCB available and it's open. I can search for the 3D option and add a 3D view in here. So I'm holding down the key and that allows me to use my middle mouse button to rotate this board and look at the 3D view. Okay, so that's enough for 3D. I'm pretty sure this can bend because I've seen it in the demo. So if you're looking for bendability for your flex PCBs, it is there. Naturally, after rigid flex, we want MCAD co-design. Is that possible? Well, Xpedition Standard does have MCAD co-design. Now, what is different about that? This is going beyond the standard import a 3D model, import a 3D enclosure, import a DXF, make your PCB, and hope for the best, right? And doing a bunch of back and forth emails between you and mechanical design teams. No, what this is an integrated environment where you have your 3D models, your 3D enclosure and whatnot, and your components on a board in a sort of hybrid environment that the mechanical engineer and the electrical engineer can both use and can use to push and pull incremental tiny little updates. I'm talking about the component level, the trace level, the PCB stack up and thickness level, board outline level, and the mechanical engineer, electrical engineer can accept or reject changes. That way we can avoid the emails back and forth. Everything is very specific. The tool handles conflicts for us, and you don't have to import and export manual step models for every single little change in the design. Drastically reduces the time spent on MCAD and electrical engineering collaboration. So if you were to go into 3D, you can do the MCAD collaborator. That should launch it. And then you have your files like local, external, local default, and the type of communication you want. You could set it to millimeters, set it to whatever units work for both teams, electrical and mechanical. Then with your collaboration data, you can set things to be updated and accept or reject changes. Mine is not set up, but it is completely possible. And this is going beyond the standard electrical engineering and mechanical CAD workflow. Drastically reduces the time spent on, and also reduces the errors that you would encounter normally. I had to deal with this when I was working at Canon, and man, the emails were back and forth, and then we had to set up a real meeting and then look at it and then measure it and estimate things, and it said, okay, you need to change this because the bend radius on these cables is too much. It's a real huge time saver. Now let's look into routing. Since we understand that you can work efficiently with the mechanical engineers and whatnot, and especially for component placement, what about component placement and routing? Now, Siemens Xpedition does have placement recommendations. Basically, what I saw from the ads and everything, you can cross-probe from your schematic to your PCB, place your components, like go into Component Explorer, then you can double-click on a component and place it. You can place them by groups. You can rotate with Control R, and that's your standard placement. There is smart placement that assists you in placing them in groups and place them in rooms, just like you would any other way. And you can, there's a special little thing where you can have parts spread apart further and come together closer while you're placing them in a group. Okay, don't know how to do that, but very cool. The menu is a little confusing for me on how to get placement going in general. So if there's some way to fix this, change it slightly, then that'd be great. I don't know. I would put TNC Wincy at the top of this list, right? Or the audio board. Okay, I just messed that up right there. So I just put it as a subset of the audio board, and we don't want that. Anyway, so next you can do things like place mounting holes, replacing cells or components, replacing test points, auto assign test points. That's great. Swap and rotate by cell name, swap by part number, and manual swapping of parts, right? Next is routing. This is big. So you can do your standard routing and doing fan outs. Fan outs are very important for time saving and efficiency, interactive tuning of traces. So it has things like accordion, trombone, notch, and all these for delaying signal propagation. That is so you can length match effectively. And be careful with that though in general. Well, if you already know how to design high-speed PCBs, I don't need to tell you that. But it has the options for length matching and signal propagation delay. Okay. In your routing, you can also swap gates. This is especially useful for memory chips and their banks of memory. So you can swap them and make routing much easier for you. You can add teardrops for signal integrity purposes to reduce the impedance mismatch, and also for a better just mechanical performance of your pads. So this is a good design for fabrication function, especially on flex PCBs, and also for signal integrity. So I like that it has all of this for routing, and then you can actually route in groups as well. So if you select your nets and your routing, you can do sketch routing and route in groups, meaning multiple nets at the same time. Set your destination to where you want to route all of your nets. This is especially useful for DDR signals like a group of DDR signals like these. And then the software tool will automatically just route all of them according to the constraints, signal propagation, delays, and everything that you set in the constraint manager. This is why I like the fact that it has high-speed constraints in here. So this is all part of the standard package. There's more that I could go into, but time is limited. This is just supposed to be a first of review here. And yeah, this looks very capable, for more than capable for high-speed trace and routing. Now, what's really important is the design rule check, the DRC. Once you're done with your design, you need to be able to check this thing. So under analysis and reports, you have DRC visualization, a hazard explorer. You can do batch DRC, choose the design status or show that to make sure you are within your limits. Then manufacturing outline hazards, package instance. So let's take a look at the design status. This gives you a comprehensive view of everything that is a warning, an error. Okay, so now let's talk about cost and licensing considerations. Given that this software can do high-speed constraint management, it can also do rigid flex design, MCAD co-design. I don't see harness design in here. You could do part search and get a board going and everything. The user experience is kind of meh, but still has all the features you need to get high-speed boards done. I think $3,000 is a fair price, the USD. And $249 a month, that's manageable. This has everything you need to get high-speed boards going. If you need to dig deeper into signal integrity, power integrity, the add-on is another $2,000 per year. You have collaborate. Okay, so it does have collaboration. It has workflows that could be intuitive if they just move a couple menu items along. Built-in versioning, project history summaries, and check-in comments. Great, so it does have those. Token-based add-ons, pre-layout simulation, rigid flex design for Xpedition. So it looks like an add-on. I'm not sure if this activate powerful design options like rigid flex design only when they need them. Oh, okay. So rigid flex design does not come standard is what I'm seeing. But then why are they showing this? So is it rigid flex in the standard or not? Maybe it is in standard because that's what I see. Now let's say you have a bunch of licenses and software tools that you barely use. That's wasted money. And what Xpedition Standard does is it lets you access these tokens. They're paid for separately. HyperLynx lets you launch. That pulls so many tokens from the pool, somebody else can open like HyperLynx or rigid flex feature that pulls some more tokens from the pool. So now you have 2 or 3 people that can work on the same or different tool without needing to have a fully dedicated, say, HyperLynx or fully dedicated rigid flex extension. Well, not extension, but license. So if you need HyperLynx signal integrity analysis and whatnot, or rigid flex, you can activate it from standard and just pull tokens. This lets you use your advanced features in the moment. You don't need to do advanced education and training for a whole complete other dedicated license. And you could think of this like a shared tool library. When I go ahead and close HyperLynx or the rigid flex, the tokens get returned back to the pool and somebody else can use it. I like the flexibility of this because this allows me and my team to, like, say, innovate. If I'm working on a team, we can get things done faster without having to worry about holding a bunch of licenses for tools we'll barely use. Yeah, I'd say overall, this is a good buy. This is a good buy or purchase. There just be some learning. You'd need to do the part search and whatnot and to use the tool. But yeah, this is a solid buy and a reasonable price. $2,000 a year would be maybe a little too cheap for what they're offering here. $3,000 is good. $4,000 is decent. I'd say that'd be pushing it a little, but possible. Yeah, $3,000 is definitely the sweet spot for this one. As far as add-on cost for, I guess, detailed rigid flex or whatever, it seems like it's in there already. I don't know. For signal integrity and whatnot, that's fair. They do it at an extra $2,000. I'm pretty sure I mentioned that for the token-based usage. And it's not like you're going to be using those all the time. So, and the fact that the tokens are exchangeable and they're not used up fully or whatever, I don't know how that works fully, is good to know. For deployment, it's easy to install. It's easy to get started and set up because it's online cloud licensing. The technical support I have not tried. Immediate available training resources. I have my detailed rubric here, but here is kind of a summary of how I would score this thing. What does this do exceptionally well? I'd say maybe the routing features that are available are good. How it handles the Constraint Manager tool in general is great. It's not overwhelming, oddly enough, even though there's a lot going on there, but they managed to make it work. The notable weakness is being able to find what I need to find and how it's organized. It messes with my flow. Okay, how tied are you to this vendor's ecosystem? Depends, you know. So I'd say based on those alone, those are some questions you can ask and things you can assess. Thank you so much for watching this video. Let me know if you have any questions and if there are other tools you'd like me to review in depth or to compare specific features to with this software versus other software tools. Thanks again. This is to help you make better decisions in buying the right ECAD software for you. I will see you in the next video. Peace.